Okay, let's see. Yep. Let's see. Or what should going as for Halloween? I'm not going out. I stopped going out once the temperature dropped below 20 degrees Celsius. So since then, I've been staying at home without going out without stepping out at all because it's too cold outside for me. So I'm not going out. I guess 102 midterm is gonna be dressed. Do you actually look like that? Yeah, I actually look like this. I just got so scared. I don't walk my dog anymore. I asked my boyfriend to walk him because I don't want to go. I don't want to go out. So either my sister or my boyfriend will walk my dog. I don't walk him anymore. I just like stay warm indoor. Anyway, some of you might notice that I'm recording this tutorial. You know that I never record this tutorial. Why am I recording? Determine if the statement is true or false. If the weather is less than 20 degrees, they will be indoor. I'm basically indoor anymore. I don't like going out, so quarantine is perfect for me because I don't have to go out anymore. I can just stay at home all day, every day, 24/7. So I'm basically an indoor anymore. But when it's less than 20 degrees, I actually stop going out. I don't even go out for groceries anymore. I actually don't even go out for groceries anymore. I asked my sister and my boyfriend to do everything. Anyway, back to back to my point. I said today I'm recording this tutorial because look at this. We have 8 questions. And you know that I never finished 8 questions. What does that mean? I will do half of the question in this tutorial and another half in my other tutorial. And I'm recording both. So you can get solutions for all questions. And I'm also covering for my loved area for one of her tutorial. So that tutorial will be recorded as well. And for that tutorial, we're doing different questions. We're doing the questions that Ariel wants to do. And that one has 5 questions. So today, in total for 102, we're doing a lot of questions. What time is the other tutorial? So I am teaching 12 to 1 for 102, 12 to 1, 2 to 3, and also 5 to 6 today. But anyway, so that's my plan. In this case, we can go over as many as I could. Hopefully I can go over as many as I could. There's no guarantee. Or so I'm making a checklist. I had one checklist before, but it's not complete. I can show you this actually. So for the meter, this is my checklist. I'm adding all the videos corresponds to each topic here, and I will tell you what I think about the meter, what are my guesses and predictions. Of course, it's not going to be 100% accurate, so don't rely on me too much. It's still in progress because I'm changing it based on what I had before. But now I have many more videos, so it's gonna be a long list. But anyway, that's another thing I am doing. Go back to my iPad. So today, I know you have a midterm tomorrow, but I have to do this because we never talked about contrapositive and contradiction. So this has to be done. We have to talk about this. No time for review, but every other topics we did them many times. They're either tested before in your quizzes or it's not so hard. At least I don't think it's so hard for the logic part. You guys were doing pretty well as well, so hopefully that's not too bad. For this tutorial, we will do 2 questions from contrapositive and 2 questions from contradiction. Okay, and I'll show you the other questions. You can have a look at it as well. So contrapositive. Contrapositive is for when you have P implies Q. So this only works when you have P implies Q. If you don't have something looks like this, so then you don't have contrapositive. And also make sure you know that the contrapositive of a statement is logically equivalent to the original statement. So in other words, this I talked about it before, but in other words, P implies Q is logically equivalent to negation Q implies negation P. So why do I want contrapositive? Because sometimes it's pretty hard to prove this. And if you prove it's contrapositive, it's much easier. So when do I want to use contrapositive? It's the worksheet posted. Did I forgot to send it to you? Maybe we forgot to send it to you. Hold on a sec. Let me find my worksheet. Okay. Oops. Why isn't it working? Okay, it's sent to you. Now, so when do I use contrapositive? We want to use it when you have if. So contrapositive, let's say contrapositive, a lot of professors really like to test you on even odd questions. So let me give you some example. They ask you to prove if a really long expression, so is even or odd, doesn't matter. Okay, then for example, x is even. Something like this. If they give you something like this, to show that to getting from a really long expression is even reduced to x is even is pretty hard. So in this case, you can prove it's contrapositive, because if you assume that x is odd or even, doesn't matter, you can just assume this equals to 2k or 2k plus 1, and then use that and plug it back into the long expression. That's going to be much easier. So this is one type that we usually use for contrapositive. Another type is they said prove if, let's say if something does not equal to something, then something equals to does not equal to something. So does not equal to is pretty hard as well. So if you prove it's contrapositive, it will be if something equals to something, then another thing equals to another thing. That's going to be much easier. Okay, so those are you usually use contrapositive to prove those. So we want to start with something simple, or we want to start with something equal. So if they have if something no, something done, something no, something, you can use contrapositive as well, because we don't want no, we want yes. Okay, so if you have something like that, you know, oh, I need to use contrapositive. Okay, actually most likely you'll be given the method you need to use, but in case they do not give to you, you can use this way to decide what method you need to use to prove. So that's contrapositive. Let's do the first. Let's do the first question. So let x be a real number. Prove that if x cubed plus 5x equals to 40, then x is less than 3. If done, and this is really long, this is short, what do you mean? What does this mean? This means you need to prove it's contrapositive. So let's prove it's contrapositive. Can someone tell me what is the contrapositive of the statement?
If x bigger or equal to 3, then x cubed plus 5x does not equal to 40.
Okay, that is great. If x is greater than or equal to 3, then x cubed plus 5x is not 40. So this is what we want to prove. Then how do we prove? How do we prove it? Yep, go ahead.
So since x is bigger than or equal to 3, x cubed has to be bigger than or equal to 27. And
Okay,
5x
we can do them
has to be
together
bigger
actually.
than or
So
equal to
this is gonna be greater than or equal to 27 plus what?
9. Not 9, 15.
15 equals to
That's larger than 40, so that's 42.
42, which is greater than 40. So that means this is never gonna be 40.
Mhm.
Okay, this is a really simple example. So that's it done. Okay.
Or could you repeat when should we use contrapositive to solve the question?
It's written here. Okay. Anyway, this is a really straightforward question. Let's do another one. Let's do, which one do I do? Let's do number 4. Okay, so I want you to use proof by contrapositive to show that if the product of 3 integers are even, then one of the term must be even. Before you do anything, okay, be careful with your contrapositive. This is a past quiz question and I marked this question. It was done very, very poorly, extremely poorly. Okay, the average of this question was really, really bad. Why? Because people got their contrapositive wrong. So think about it carefully and tell me what is my contrapositive. Okay, I already see different answers. Any one of you want to change your answer after you looked at other people's solution? What is after if? This is where most people get it wrong. Okay, what is this? What is a negation of one of the term must be even? That's what you need to think. Okay. This can be rewritten as one of the term must be even means if you have, let's say, x1, x2, x3, then this means there exists xi from x1, x2, x3 such that xi is even. So what is the negation of this? This means for all xi in this, xi is odd. Okay, so that's my negation. If x, y, z in this are all odd, this is the first common mistake. Okay, then x times y times z is odd. This is my contrapositive. So this is the first common mistake. A lot of people think you have one of them being odd. That is incorrect. Okay, that's my first common mistake. Now, another common mistake is coming. Let's say suppose x, y, z in integer are odd. What does that mean? What can we do? then what? Anyone? If X, Y, Z are all odd, then what do we have? What do we have? All terms equals to 2k plus 1. That's the second common mistake. Nancy is right. Okay, you cannot use the same variable for all three of them. Okay, has to be different. That's the second common mistake. So many students use the same variable for all three of them, but they are not necessarily equal. You know, if you use the same variable, that means they are all equal. That means X equals to Y equals to Z, but we don't know. Okay, we don't know if they are equal, so we cannot use the same variable. That is the second common mistake. And that is why this question was done poorly. So then we can write X equals to 2a plus 1. A is an integer. Y equals to 2b plus 1. B is an integer. And Z equals to 2c plus 1. C is an integer. Okay, this is a second common mistake. Okay, my A, B, C, they cannot be the same variable. They have to be different. Oops. Okay, I only wanted to change A, B, and C. 2c plus 1. This is the second one. And the rest are easy. So if you don't make mistake here and you don't make mistake here, then you're almost done. Then X, Y, Z is 2a plus 1 times 2b plus 1 times 2c plus 1, which equals to 2 times 4ab c plus 2ab plus 2bc plus 2ac plus a plus b plus c plus 1. Okay, since this is an integer, we know X, Y, Z is odd because we can write it as 2 times the integer plus 1, which is odd. So that's it. That's the end of the proof. Let's see. If we already proved all times odd is odd in one of the problem set, could refer to it. You don't need to prove it. You can use it as a base effect. Something like odd times odd is odd, even times even is even. You don't really need to prove it. Okay? Or plus, like even plus odd, something like that. Odd plus odd. You could, but you don't have to. You don't have to. We're not that harsh. Could this be shortened? Oh, for this one, if you want to use all times all, I think part of the marks were deducted because the whole question is basically asking you to prove all times all is odd. You know what I mean? The whole question is asking you to prove it, so you cannot really say, oh, that's it. A, B, C are just any integer. Yeah, it's basically asking you to prove all times all is odd. Then it's like the question is asking you to prove it. You cannot use it directly to prove the question because the question is asking you to prove it, right? Yeah, This is just saying they are any integer. We know that 2 times an integer plus or minus 1 is always odd. So they could be any integer. The thing is they cannot be equal. They're not the same integer. Okay, any question? Question? Cool. So for the question like function has no rational solution type, can we just make a statement? Yes, you can. Because well, the question is not asking to prove all plus all is odd, something like that. So we can just use it directly. As I mentioned, this one you cannot use it directly because the whole question is asking you to prove it. So you cannot use something you need to prove a question, right? However, for something like this, we don't really need to prove anything because it's pretty simple. Okay, well, let's do, which one do you guys want to do? 5, 5, 6, 7, 8, which one? Pick 2 and we'll do 2. 5 and 8. 5 and 8. Okay, cool. Let's do 5 and 8. So 5, prove that. Oh, before we do that, let's talk about contradiction. So contradiction is basically you assume that, so when you have P implies Q, you assume that both P and negation of Q are true. However, proof for contradiction, you don't necessarily need P implies Q. You can just have one single statement. And what you do is you assume the negation of these statements. So what we're doing is we assume negation of the original statement. Okay, so here we assume, oh, this is not working. Let me change it. Okay, we assume the negation of the original statement and try to derive a contradiction. That's what we're doing. Okay, that's what we are doing. Now let's do 5. Prove that there are no rational solutions to the equation. So this is a typical contradiction question. For contradiction, it's most likely the statement has no, not, something like that. So when a statement has negation words, such as no, not, never, cannot. Okay, something like this, you know that you need to use contradiction. So if they say no, you assume yes. Similar to that, okay? So in this case, prove that there are no rational solution. No is a word to tell you it's contradiction. Okay, this is just for 102. If we talk about higher level math for contradiction, something like infinite would also be in there because it's really hard to deal with infinity. So if you assume it's finite, it's much easier to deal with. So for upper year courses, we will see infinite, that's another signal for contradiction. Anyway, let's do this. So for contradiction, let's suppose we have a rational solution. So let's suppose there exists, what do we use? Let's suppose there exists x in Q such that x squared plus 1 over x squared equals to 3. Since x is in Q, we can write it as, then we can write x equals to m over n. Okay, and those conditions are quite important. You have to have all of them. Okay, the first one is m and n are integer. N cannot be 0. And the third one, m over n is in its lowest term. What does that mean? This means that another way to say it is the GCD of mn equals to 1. Or you can also say that m and n are relative prime. Okay, all of them works. I do not suggest you to say GCD of mn equals to 1 because we're not there yet. GCD means greatest common divisor. We're not there yet, so I do not suggest you to use this in case your TA think, oh, we're not there yet, so we cannot do it. So I would suggest you to use this phrase or this. Okay? But anyway, this is what we need to have. All three, we need to have all three because this one will reach a contradiction later. This one will give you a contradiction later, okay? So now you can plug it back in. So m over n squared plus 1 over m over n squared equals to 3. We don't like rational numbers. We like integers. So you want to get rid of the fractions. Okay, we don't like fractions. You want to get rid of the fractions. So you want, what do you need to do? Multiply by m squared on both sides. So that's going to give you m cubed plus, no, not cubed, to the power 4 plus n to the power 4 minus 3m squared equals to 0. Okay. Now you need to discuss cases. First case. If m and n are both odd, then what do we have? We have odd plus odd minus odd. This should give you odd equals to 0, but 0 is an even number. So this is a contradiction. Second case, when they are both even. Then m over n is not in its lowest term because m and n are not relative prime anymore. So this is a contradiction. You don't need to, that's gonna waste too much time. Just say if even plus even is even, odd plus odd is even, something like that, okay? And the third case, if m is even, n is odd, even to the power 4 is still even. So we have sorry, I have a code. So we have even plus all to the power 4 is still odd, minus 3 times even times odd. So that's gonna be even. Even plus odd minus even equals to odd is 0. Contradiction. Oh, by the way, this is a symbol for contradiction if you didn't know. How did I get from the first step to second step? This? You just 1 divide by something is 1 multiply the reciprocal of that, remember? So you this becomes to the top. And lastly, if m is odd, m is even, then we have, what do we have? We have odd plus even minus even equals to odd, which is 0, another contradiction. So we're done. Question? Go ahead.
Oh wait, sorry. I just had a question regarding, like, if we had a different question where we were taking cases and one of them was true and wasn't a contradiction, then
You don't have a contradiction.
okay.
Yeah, you need all 4 to be contradiction.
To prove that that like the original statement was true, right?
Mm-hmm.
And
Yes, exactly. I use that for contradiction too. In my assignment, I actually use this. Oops. Oh, I actually use this. Where is it? This. I actually use this for contradiction. I did that too. So whenever my TA see this, they know it's me. But anyway, yeah, you can use the symbol. I think your TA should know the symbol. If they don't, it's okay. If they don't understand, I understand you, so it's okay. So you can just ask me for a remark. It doesn't really matter. Okay.
Yeah, I had a question regarding 2 things. First of all, isn't the GCD meant to be also -1? Because in like the textbook, it was saying the GCD of M and N is 1 or
GCD is
-1.
what? -1?
Yeah.
No, GCD is always a positive
Oh, is it all
number.
positive? Okay. 'Cause like I
Yeah.
was reading the textbook. Oh, the GCD. Oh, it's okay. I got it now. And then also at the beginning, you said suppose that there exists X. Aren't we meant to give it an arbitrary number R? Because that's what they did in the textbook. So I'm just wondering if that's
Well, my X is an arbitrary
okay.
number as well. It doesn't
Oh, so
really
this is
matter which
okay.
variable you're using, right?
Oh, it doesn't matter? Okay, because I thought it was important.
No, it's just you just picked a random variable. Doesn't matter. You can use A as well if you want to. It doesn't really matter. You don't need to use X. You can even here you can use A over B or P over Q, something like that. Okay.
Okay,
Another
got it.
hand up. What is your question?
oh
Lower
no,
your
you
hand
answered my question. My bad.
All right. Oh, seems like I have more time. Let me think if there is anything I wanna emphasize. Oh yeah. I do wanna mention something. If you notice that here your M and M, even if you switch their position, you get the same equation. Did you notice that? In that case, you probably can combine those 2 cases together. So you can say without loss of generality, suppose M is even and that's all. I do not suggest you to do that, Okay, I know some of you are doing that. It is correct. I do not suggest you to do that because many of you still don't even know what without loss of generality means. A lot of you don't know. Some of you know, but you don't fully understand it. So I've seen it being used incorrectly many times in this course. So unless you know, you definitely know what you're doing, then don't use it. Don't use it until you actually know what you're doing. Okay, that's what I want to say. Because, for example, if here is not to the power of 4, if here is to the power of 2, or to the power of 3, then you cannot use it anymore. You have to discuss for all 4 cases. So to be safe, okay, safe option is you always discuss 4 cases. Don't use without loss of log. I like it a lot, but I never used it in 102 because I don't want to let you think you know how to use it, but you actually don't. Okay, does that make sense? I see some people are discussing what if some situation work and others don't. Well, it's either your statement is false or you just didn't prove it in the correct way. And we would never ask you to prove a statement is false. So if we ask you to prove something, that's definitely a true statement. Don't tell me the statement is false. It's definitely true. Okay, so that's what I want to mention. Safe, to be safe, never combine them. Unless you know what you're doing, never combine them. Okay, if you know what you're doing, if you know when we can use without loss of generality, then go ahead. But if you don't think you fully understand it, then just be safe, because you will lose mark. Okay, can I explain this? This is what, if they are even, then those two numbers are not relatively prime anymore because they have a divisor which is 2. So that contradicts with my assumption here. Does that make sense? Okay, let's do one last one. Some of you said 8. Let's do 8 then. So look at 8. 2 squares from each of the 2 opposite corners are deleted from a checkerboard. So this is a checkerboard. Prove that the remaining squares cannot be fully covered using copies of T-shapes and their rotations. So I didn't put it here. The T-shapes means this. So you either have this, and this is white as well. So this is one of the T-shape. You can rotate it as well. That's what they said. So this is one of the T-shape, or you can have another T-shape that those three are black, but the middle one is white. So this is another T-shape you can use. So you can combine those two, and they are asking you to prove that you can never fully cover this using the T-shapes and rotations of them. So what do we do? I'll let you think about it for a bit, for 2 minutes. I don't need 10 minutes, so let you think about it for 5 minutes. How are you gonna prove it? Yep. There are actually multiple ways to prove it. They all require contradiction. What do you mean doesn't add up? Well, one white, one white, and one black and 3 black adding together, that's still even number, right? You can have either even number or odd number of them. If you want odd number, you can use this or only this. If you want even, you add them together, or you use two of this, you can get even number. So think about why. Think about how are we gonna do this? We know it's definitely contradiction, so you need to assume that it can be fully covered using copies of the T-shapes. But where is your contradiction? I'll give you 3 more minutes. Let other people think, don't spoil it. If you got it, don't spoil it. Let other people think as well. This was actually in your textbook, but it was on a past test as well, many years ago. So sometimes they give you contradiction questions that are really simple, such as what we did before, like show there are no rational solutions or natural solutions, integer solutions. Those are classic contradiction questions that everyone can do. But in other time, they give you something like this. Or I've seen many different types of contradictions. So you should know how to do all of them. Keep thinking, keep thinking. It's actually not a hard question. And it's actually similar to questions we had before. Not the ones we did before, but another question that's similar to this. Actually not similar. Never mind. Has some similar logic, but not really. I'll give you 1 more minute and then I'll take it up. Okay, let's do this. So for contradiction, once I take it off, you'll see how simple the question is. For contradiction, okay, sorry, I apologize. I should not say the question is simple because people find me intimidating for saying questions are easy or simple. I apologize. It's not simple. For contradiction, suppose the remaining squares cannot be fully covered. Oh, can be fully covered, sorry. What did I do? I just copied down the original statement. Can be fully covered using the T-shapes. Okay, so that's what I'm. uh, sorry, I apologize. I'm improving already. Okay, I'm improving already. When I first here, I always say my sister can do this, and she's in high school, and people were like, "You made me feel stupid," and I don't say that anymore. Um, but I was telling the truth. My sister actually can do it. She got perfect on 102 when I gave her 102 tests and quizzes. And she was around, let me think, grade 8. Now she's in grade 12. It was like grade 8 or grade 9 or something. But the difference is I one-on-one tutored her. I one-on-one taught her everything. You guys didn't get one-on-one stuff, so that's the difference. Anyway, back to this. So the point is not about, it's not about something like what you guys were thinking. Oh, this we remove too. It's about we can never use those to get those. So we need to calculate how many black squares do we have and how many white squares do we have. So in total, we have, so we can count. Each row has 4, and we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 rows. So 4 times 8 minus what? So before we remove it, this one should be black. This one should be black. So they remove 2. So it's minus 2, which equals to 30. So we have 30 black squares. And similarly, 30 white squares. Okay. Sorry, I should never mention that. Now, since you're saying we can use them cover the whole thing, that means you can have copies of them to make up 30 black and 30 white. So let's suppose we use 8 copies of this one and B copies of the next one. Then you can make 2 equations, right? Since you have 8 copies of the first one, you will have 3A of white ones and plus B equals to 30. So this is for white square. And also A plus 3B equals to 30. This is for black squares. Oh, not square. Oh my God. Oh, never mind. It's okay. It's squares. I was being stupid. Now you solve for this equation and you'll realize that, well, they cannot be integers. Sorry, I should have A, B are integers. In fact, they have to be natural number union 0, not just integers. Okay, and you solve for this. So let's call it this 1, let's call it 2. Then 1 times 3 give you 9A plus 3B equals to 90. Let's call it 3. Then 3 minus 2 will give you what? 3 minus 2 is 8A equals to 60. Then A equals to what? 60 over 8 divided by 4. So that's 2, 15. which is not in this. So that's my contradiction. Where is my contradiction? Okay, so this is my contradiction. Okay, so the proof is down.
Do we also need to solve for B?
You don't really need to because A already gave you a contradiction, but of course you can do it. Where did I get 3A plus B? So we used A copies of this. A copies of this, each copy has 3 white square. So you have 3A copies, 3A white squares from this. And similarly here, you use B copies of this. Each copy has 1 white square. So you, in total, you have B white squares. Adding them together should equal to 30. Does that make sense? Okay, let me go back and see what's in the chat. I guess she makes posts next year. She's not doing CS. She's not gonna do CS. Or even in her pets 102 in the DNA. I need to teach my dog counting first. Off-topic question, but is it possible for our answer to be true? Answer to be true? But when we try to cover it in real life, it doesn't work just based on how. Huh? I don't think I understand your question. So whenever the question asks to prove no something, we should prove by contradiction. That's a signal for contradiction, but it's not 100% accurate. So sometimes you don't really need contradiction. This is this times 3 because I want to solve the equation. This times 3, you get this, then this minus this can get, so those two canceled out. So you'll get 8A equals to 16. It's just I'm trying to solve it. You should show us how you solved it, right? Are you gonna be marking our meter? I'll probably mark one version of one question. All the TAs are marking on midterm, so I'll give them each one version of one question or 2 versions of one question, something like that. The decision will be made tomorrow, probably during your midterm, because I haven't seen your midterm yet, so I cannot decide who marks what, because each TA has different marking hours. I need to see the midterm first before I make the decision. Okay, any other question?
So for this question, do we need to conclusion? Like the original one is true.
Well, you can conclude it from here. Yeah, you don't have to, but it's better that you do.
Okay.
Why 3 minus 2 is a contradiction? Oh, because once you solve for A, you know that A is not an integer, but your A has to be integer. That's the contradiction. This is not, but we assume that it has to be. You can not have like 15/2 copies of A. You either have 1, 2, 3, or 0 copies of A, right?
So if we want to write the conclusion, it should be by contradiction, the original statement is right.
Just say so the original statement, or say so our original assumption is wrong, hence whatever we proved is correct. I lost where you got the equation 3A plus B. Again, 3A plus B, you got 3 copies, you got 3 white squares from this and 1 white square from this. You have A copies, so it's 3A. You have B copies, so it's B. And you add them together should give you all the y squares. Does that make sense? Okay,
Oh yeah, do you
last,
also, do you also have to label the 1 times 3 thing? Like let equation 1, that equation 2, or no?
No, you don't need to worry about that. Just show us how you got the final answer.
Okay.
Last question, and I have to go because I have another tutorial.
So I just have a question. So like, I'm a bit confused on how we derived to get knowing that there's 30 black squares and 30 white squares. Like, I know you did 4 times a minus 2, but where did 4 times a minus 2 come from?
4 because each row has 4. 8 because we have 8 rows. -2 because you remove 2.
Oh my God, okay.
Okay.
Okay, thank you.
All right, am I gonna post last week's tutorial answer? Yeah, I will. Okay. The PDF. I didn't I send you a PDF already? Can someone send the PDF again? Let them get the PDF, and then we can go. Someone send it again, because apparently some of you didn't get it. Checklist, I will post it on my page, Quarkus page. Okay. Okay, I have to go. Bye. Bye, guys. Bye. Bye. Get out now. ASAP, or I'll kick you out.